Hello guys, I'm Dhruvil Patel, you already know, and I'm back here with a new course. So, in this course, we will study about the various types of force occurs on the body. Basically, this is a part of the mechanics of solids. Okay, so let's start with the course. I hope you will enjoy studying with me. So, this is force. So, the question comes in the mind, what is force? Force. Basic definition is a force is one type of agent. It's one type of agent which produces or tends to produce, or I can say that which destroy or tends to destroy the state of the body. Tends to destroy the state of body. As an example, I can say that if I am standing here in a static condition, then someone pushes me from the back side. So I will move from this side to this place. So it means that an agent that change my state of the body. Okay, from static to dynamic. So it is known as force. One figure I can say that this is one element which is in static condition. I will apply force from here. So the body will move from here to here because of force. Okay. So what are the effects that on the body by force? So effects on body, change the motion of body. If it is in static condition, that it will be after force it will be in dynamic condition, or retard the motion of the body. Suppose if the body is in moving condition and we apply the force from the opposite direction, like one vehicle is moving in this condition and we apply force from this condition, this side, so it retards the motion of the body. Okay. Second, balance the force acting on body. So if the 10 kN is from here and the 10 kN is from here, then it will be in balance condition. Okay. And the fourth point is give rise to the internal stresses in the body. If the body is moving in this side, this direction, and we apply extra force from here, then it will rise in the stresses in the direction of the body. So these are the four effects occurs on the body regarding the force. Okay. Here I have stated the definition of the force. Agent that produces or tends to produce, destroy or tends to destroy the state of the body is known as force. And it has its unit. Like my name is Dhruvil Patel and my unit is Patel. Likewise, force also has its unit. There are two systems, MKS system and SI system. In MKS system, the unit of force is kilogram force. In SI system, unit of force is Newton. Force is generally denoted by P, or we can say that F. Okay. 1 kilogram force is equal to 9.81 Newton. As we discussed before about the force, now moving towards the types of force. There are various types of forces, like I will make a chart, like coplanar forces, the force which occurs in same plane is known as coplanar force. In same plane means, suppose here is a body. There are three planes. First one is here, second one is here, and third one is here. horizontal, vertical. These are the planes. Okay, x, y, and z. The force which will occur in this plane only, then it is considered as coplanar force. If the forces are occurring in different planes, then it is considered as non-coplanar forces. Means I can say that same plane, and here it is different plane. In short, we can remember like this. Okay. Another one is concurrent forces. The force which occur at single point is known as concurrent forces. Single point means, suppose this is one point. Force occur here. Here only, then it is a concurrent forces. In short, at a single point. Another one is non-concurrent forces. At different points, means one is occurring at this point, another one is occurring at this point, another one is occurring at this point. So it is known as non-concurrent forces at different points. Now, if you understand these four basics definitions, then you will also understand the above definitions like coplanar concurrent forces, in same plane at a single point. Means this is one point and the force is, this one is one point and the force occur here, here, here. If this is one point here and this is one plane, the force will occur here, here and here. So this one is in same plane at a single point. So it is known as coplanar concurrent forces, in same plane at a single point. Likewise, non-coplanar, we can also say that coplanar non-concurrent forces. So, this is the different points. 1, 2, 3, 4. At this point, at this point, at this point, at this point. But it is in same plane, but at different points. In same plane, and at different points. So it is coplanar non-concurrent forces. Same as here, non-coplanar concurrent forces. At different plane, but at a single point. I mean, this is a single point. One force is occurring from here, one from here, and one from here. So it is in different plane, three forces, but occurring at same point. Then it is non-coplanar concurrent forces. So, in different plane and at a single point. Now, another one is non-coplanar non-concurrent. At at different points from different plane, here, 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 in different plane at different points. This all is the definition of the different types of forces. There are more forces. Let's see another one. Okay? Let's revise the definition. First one we see coplanar forces, which is in the same plane. Non-coplanar forces, which occurs in different plane. Concurrent forces at a single point. Non-concurrent forces at different points. In coplanar concurrent forces in same plane at a single point. Coplanar non-concurrent forces in same plane at different points. Non-coplanar concurrent forces in different plane but at a single point. And non-coplanar non-concurrent forces in different plane at different points. Okay. Now another type of force is like parallel forces. The forces which are parallel to each other is known as parallel force. If the force occur on this body, it's like this. The spacing between these two is same. Then they are parallel forces. In parallel forces, there are two more types, like parallel forces and unlike parallel forces. How we can differentiate these two forces? The like parallel forces are, it means the direction of the forces is same and the spacing between these two also is same. Then it is considered as a like parallel forces. But if the direction of forces is different but the spacing between these forces are same, it means the direction is different the spacing is same. Means all are at equal distance. That is considered as unlike parallel forces. So these were the terminology of the forces and the types of forces. Resultant force. It states that a single force which produces same effect as produced by all other forces. One element is consist of different type of forces. Okay. But the resultant is that one force which produces the same effect that all other forces together produce. If I can take one point, one force is occurring in this direction, P. Other one is occurring in this direction, Q. Okay. These two forces is in different direction and at one point. The resultant of these two is here, which produces the same effect that is being produced by these two. Okay, and it makes the angle with the largest force, which is the bigger force. Okay, and it is considered as alpha, and the angle between these two is considered as theta. So we need to find the resultant force. and the method for find or the load for finding the resultant force are as given. The first, loss for resultant force. First one is law of parallelogram. Second one is law of triangle. These two laws are used to find the resultant force. Let's understand these two laws. First one is law of parallelogram. The statement of law of parallelogram is, I will explain you by figure. This is one is parallelogram. Okay. These four sides of parallelogram. Okay. This one is a point. Two concurrent forces acting on a parallelogram by two adjacent sides. First one is P, second one is Q. The angle between these two is theta. Okay. Then the resultant force of this is the diagonal of the parallelogram which start from the intersection points O. It is considered as R. And the angle of R is at alpha. So the statement is, if two forces of magnitude and direction, the magnitude is in kilonewton and the direction is either tensile or compressive, so, occurs on the two adjacent sides of the parallelogram, then the resultant force is the diagonal of the parallelogram. So the equation to find the resultant is R is equal to under root of P square plus Q square plus 2PQ cos theta. And the alpha is decided by Q sin theta divided by P plus Q cos theta. Tan alpha. Now there is a derivation to prove this equation. Okay. So how it is being proved? So let us consider a figure again. Let me draw one figure like this. If this one is a parallelogram, P and Q, I will take this as A, B, C, D. I will extend this to the till it becomes the 90 degree at the D point. The point is E. Okay. Consider the AB as P, AC as Q. If the AC is Q, then the BD will be also Q. BD will also be considered as Q. Okay. It means if AB is equal to P, then AB plus BE. So what will be the BE and ED value? So let's draw this portion. We need to find the resultant. Okay. So we will consider the triangle A, E and D. A, E and D. Okay. We will consider the triangle A, E and D. Somewhere here the B point is there. This is P, this is Q and this is R. Now this is the right angle. It means this is the nearer side and this is the hypotenuse side. This is the farthest side and this is the hypotenuse. Okay. So it means that we need to find the BE value. So by using the sine cos formula, we can say that cos, this is theta, so this will be also considered as theta. So we can say that cos theta is equal to BE by BD. Okay, we have the value of BD. Cos theta is equal to BE by Q. It means BE is equal to Q cos theta. Same as sin theta is equal to DE by BD. So DE is equal to Q sin theta. That means the value of DE is Q sin theta and this is Q cos theta. Now we need to find the resultant force R. So applying the Pythagoras theorem, which is AD is equal to under root of AE square plus DE square. So AE is equal to AB plus BE whole square plus DE square, and AD is equal to R. AB is equal to P plus BE is equal to Q cos theta whole square plus Q sin theta whole square. So the equation will be P square plus 2PQ cos theta plus Q square cos square theta plus Q square sin square theta. I open up the cons. Now you can write it P square plus 2PQ cos theta. Let me common the Q square value. Q square is equal to sin square theta plus cos square theta. Now we all know that sin square theta plus cos square theta is equal to 1. That's why the equation will be P square plus 2PQ cos theta plus Q square. Equation of R. Okay, I hope you all understand that's how I find the equation of R. Now find the value of alpha. So how we will decide the value of alpha? How we will decide the value of alpha? So here is the alpha. If this is the alpha, so I will use the equation of tan alpha. This is the D by A. So tan alpha is equal to D is the value Q sin theta and A is equal to AB plus BE. It means Q sin theta by P plus Q cos theta. Likewise, I have found the value of the alpha. Okay, I hope you all understand. Now moving towards the law of triangle. So the statement of law of triangle is different. Like in law of parallelogram, the resultant force if the two adjacent sides of parallelogram P and Q is a tensile or compressive force, then the resultant will be the diagonal of the parallelogram. And in triangle, if the two forces P and Q is two sides of triangle, then the resultant will be the third side of the triangle. So modifying this figure like in the basis of this P, Q, the angle here is theta. Okay, so third force is the resultant force. Okay, this is beta and this is theta. The equation is same as the law of parallelogram. Okay, now these two forces we have understand to find the resultant force. One thing you have to keep in mind, in these two law, the law of triangle and the law of parallelogram, it's only applicable when the forces are occurring in concurrent and it should be less than or equal to 2. Not less than or equal to 2, it should be 2. When two concurrent forces are occurring, then and then we can use the law of parallelogram and law of triangle. After knowing this, one question arises in my mind, that what we should do if there are more than two concurrent forces. So, if there are more than two concurrent forces, if there are more than two concurrent forces, then the summation, the resolution of all the forces, either we can say that vertical force or horizontal force, used to define resultant force. Means, if I am drawing one state, the force is acting here, 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 the force is acting here. It's one point, but P1, P2, P3, P4, P5, these all 5 concurrent forces are occurring on the plate, okay, from one point. So, to convert these diagonal forces into horizontal and vertical forces by using the cos theta value and sin theta value, okay, and then summation of all horizontal forces and summation of vertical forces we need to find. After that, using the equation of resolution, R is equal to summation of h square plus summation of v square, we can find the value of R, one single force. Okay, by summing this, we can find the value of 1R. It could be somewhere in this quadrant diagram, like somewhere here also, somewhere here also, and somewhere here also. So how we can decide that where the value of resultant will be located? So by finding the value of alpha, and the alpha value will be found by tan alpha is equal to summation of v by summation of h, mod of summation of v by summation of h, because it will be always in the positive form. That's why we are using the mod of summation v and summation of h. So we have understand that if there are more than two concurrent forces, then the resultant force is found by the resolution forces, which means the summation of vertical force and horizontal force. By using this formula we can find the value of R, and by using this formula we can find the value of location of the resultant force in this quadrant. The another theorem, okay, this theorem is lami'stheorem. It states that if three concurrent forces, in first two laws we have studied in parallelogram and triangle, that two concurrent forces need. In third law, law of resolution, we studied that if more than two concurrent forces are occurring on the element, then we can find the resultant by using the law of resolution. In this theorem, it states that if three coplanar forces acting at a point be in equilibrium, then each force is proportional to the sine of the angle between the other two forces. Now, the equilibrium means if the resultant of a number of forces acting on a particle, okay, if the resultant of a number of forces means number of forces are occurring on a particle, but the summation of that is 0, then the particle will be in equilibrium condition. Okay, so if three coplanar forces acting at a one point, let's consider this is a one point. In equilibrium means it will be in same. So first one is this P, another one is this Q, and another one is this R. Then each force is proportional to the sine of the angle, means each have their an angle. Let us assume this is alpha, let us assume that is beta, let us assume this is gamma. So proportional to the sine of the angle between other two, means if we need to find this, then this is proportional to the sine of angle between other two, means between Q and R. Means if we consider P, then it will be the proportional to the sine angle of other two. Other two means Q and R, means sine angle means sine gamma. Is equal to, if we consider Q, then it is proportional to the other two, sine beta. And if we consider R, then sine alpha. So the numericals of law of parallelogram and triangle we can solve by using that equation. Numerical resolution also we can solve by that equations, and the numerical of lami'stheorem we can solve by this equation. So let's make some quick revision. We have studied today about the force, types of force, coplanar, then resultant force, then law of parallelogram, the equation was r under root of p square plus q square plus 2pq cos theta. Tan alpha is equal to q sin theta by p plus q cos theta. Then law of triangle, then law of resolution. The equation was r is equal to under root of summation of h square plus summation of v square, and tan alpha is equal to mod of summation of v by summation of h, and then lami'stheorem is the equation. In another video, we will start solving the numericals based on this law, parallelogram, triangle, resolution, and lami'stheorem. Okay, I hope you all understand in today's topic. We will see in the next video. Okay.